Hi guys, this is Zoe Kimpel. I'm going to walk through my midterm results here. So first I took a look at the distribution of the target variable here, what we're trying to predict. And on the left you can see how the vast majority of the sales are a very small number with some large outliers really skewing that data set. On the right you can see how there are some negative transactions, which was good to note for data cleaning purposes. And again, really emphasizing how the vast majority of the data falls under having just very few transactions. Also looking at a few other plots, I looked at how shops and items were dispersed across the data. So as you can see from the plot on the left that not all sales were spread equally among the shops. This was really important for predicting the future sales for each shop. And on the right, you can see how the same is true for the items. So specifically, item 20949 was very popular among the shops, and I wanted to make sure to take that into account in my analysis. Next, looking at traditional time series exploratory data analysis, I aggregated the sales to be on a monthly basis, and as you can see, there is a decreasing trend as time goes on. With some seasonality, there's some peaks seen at the very end of the year. So important information to be taken into account during the modeling phase. Continuing with the EDA, on the left we have a seasonality plot, and so you can see how year over year those monthly aggregated transactions are decreasing over time. You can also see how the sales spike towards the end of the year, which is important since we are predicting the total transactions for November. One thing that's also interesting to me is how much smoother the 2015 line is compared to the previous 2 years. Also looking at the autocorrelation plots, the ACF plot on the top show how the first three lags are statistically significant in terms of autocorrelation. And there also appears to be somewhat of a cyclic nature in that autocorrelation, again proving that seasonality. The partial autocorrelation plot also shows a significant in the first lag there. So next I did some data prep and feature engineering. Data prep included, again, aggregating that data into a month-by-month basis and setting the negative sales, which I assumed to be errors, to 0. Some feature engineering included creating the year and month variable, as well as breaking up the shops and items into categorical bins that looked at quantile information, historical information to see which shops had high, medium, and low transactions, as well as which items had high, medium, and low transactions as well. I also created a flag variable for item 20949, which was the most popular item at most of the shops. One, because I wanted to make sure this was accounted for in the model, but two, my residuals, when I observed my models more closely, most of my largest residuals came from predicting item 20949, so I wanted to make sure that this was accounted for as much as possible. I also looked at the distribution among the shops and items, looking at the historical data so that I could create an expected value, calculating the breakdown of the shop and item, multiplying it by the final monthly forecast for the time series data. In terms of the 5 models created, I looked at 3 different time series models, the seasonal naive, error trend seasonality, as well as the seasonal ARIMA. And 2 traditional regression models I also created. One was linear regression, and the next was a Poisson regression, since the transaction data that we're working with are made up of count variables, especially low count variables, skewing that distribution. I also looked at the Poisson regression to take all of that information into account. The results so far have shown that the time series models, the best is the ETS model with multiplicative error and additive trend and multiplicative seasonality. This led to an MAPE of 8.8 on the test data. In addition, the seasonal ARIMA model also performed better than the seasonal naive, which makes sense, but not as good as the ETS model. Looking at the regression results, the Poisson regression really outperformed the linear regression against the test set with a mean average error of only 0.72. When I ran these models through Kaggle, so far the best has been the ETS model where I tested various transformations, and the best one so far has been non-differenced in the ETS MAM. Next was the seasonal remap, then linear regression, Poisson regression, lastly the seasonal naive. So this was a little interesting to me because of the model performance against the test data. It did appear that Poisson regression was way better than linear regression, so some of these results did surprise me a little bit. Lastly, some future work that I think would be beneficial would be to investigate how the shops and items change over time. I think this would really increase the accuracy of the forecast, since in my models for the time series forecast, I'm just multiplying the monthly forecasted value by the distribution seen by the items in shops. If that has changed than the past 3 years, then I think that this would make it much more accurate. I also think since the data has a zero inflation, so a lot of the data is extremely small, I think looking into some zero inflated modeling would be beneficial. I did try this, but due to the sheer nature of all the data, I wasn't able to get the model to run. Some lessons learned, it was surprising and also interesting to me how well the time series models performed when just forecasting the next monthly transactions as a whole and multiplying it by the distribution seen in the historical data. Performed much better than their regression models, and to me it seems like regression would also perform well because it takes into account the item and shop information and the seasonality and things like that. So it's interesting to me that the time series models did perform so much better. I think it's great that we're learning about this and looking forward to hearing more about everyone else's projects and finally getting all of this wrapped up. Thank you guys.